Okay, so unit 10, as far as on Skyward, this is unit 10, but if you look in notes, it's actually unit 11 on the Google Drive. So it's unit 11, and supplemental homework, it's unit 11, okay? This is going to be dealing with areas and volumes. Day 1, I did not want to add puzzle. I wanted to do it hearing fast so that you could see and ask great questions. But because there's some people obviously absent, I'm needing to record as well. It's not going to be assigned as a net puzzle, but it'll just be supplemental. So if you have to go back, you can actually look at stuff foundation-wise. All right, here we go. So what we're looking at is the area between two curves. Okay. Notice this does not say function. Okay? It does not say function because sometimes you can have a curve that does not pass the vertical line test, that you can take the area between two curves. Okay? So it says, find the area bounded. First of all, this is going to be always positive. So before, when you had like a negative displacement area, no longer is it going to be considered negative if it says area bounded. Even down here, let's say that it was normally negative 10 displacement, it would actually become a positive 10 because of the methods that we're going to be using with area bounded stuff. Okay? So here we go. Alright, so we have f of x. So let's draw a graph. And this is f of x. And then we have another graph that is g of x. Okay, and we have it from a to b. Up until this point, if I were to ask you to integrate from a to b, you would say all of this is the area. Right? And if it was below the x-axis, you would say it was the negative area. Okay? What's different now is that you don't have just one function, you technically have two. What's the second function? It's g of x. Okay? What is the second function that you've been doing this whole time that you've just been taking for granted? What is it? Y equals 0. So you've been taking that for granted this whole time, but now you could have a function that looks like way up here, where it could be g of x. Okay? And if we're looking for the area between a and b, all we're looking for is the area bounded in between these two functions that correlates with the area from a to b of f of x minus g of x. Okay, so how do you set this area up? This is how you set it up. It'll be from a to b. These are vertical slices. All these are vertical slices. And it's going to be, that's what makes it dx. And it's going to be the, in this case, the f of x minus g of x. So this can get a little confusing because let's look at it first of all. Let's look at it this way. The area of f of x would be all of this. Okay? And the area of g of x, if I were to highlight it in blue, would be all of this. But the way that I have it set up is that if I'm subtracting that blue, it basically is going to make it go away per se, to where all we have is that shaded region left over that's existing between the two graphs. That's what's happening when we set up this equation over here. You with me? Okay, now, an easier way to look at this would be from low to high. Okay, low x to high x, and it's going to be the top function minus the bottom function. Okay, we'll talk about that here in just a bit. And this is dx. That's how I want you to look at it. The low to high right here, these bounds, are saying from left to right, x-wise. So these functions right here, you tell me, they're going to be written in terms of what? They're going to be written in terms of x. Because how else can you integrate something that's in respect to x? You with me? Alright. Now, let's look at the alternative. If you are looking for things that are written in terms of y, it's because you're doing dy stuff. Okay? And you're going from the low y value to the high y value, and you're still going to do top minus bottom. Now let's look at the progression of this. Top minus bottom. And real quick, before I get into this problem, these parentheses are very important. That's where most of the mistakes occur. Like negative mistakes have occurred in the past. Just make sure that there's a parentheses right there. Okay? Alright, so like I said before, these are curves. So you could have a curve that looks like this is f of x. Whoops. F of y, that is. And then you would have g of y. Okay? And let's say that you wanted to look from A to B. You wanted to look from this valley right here, and you wanted to integrate all the way to this valley right here. So this would be like the low y value. This would be the high y value. Okay? And it would be integrated that direction. So, for instance, let's say that this was negative 3 and this was like 2, as far as like 1, 2, 1, 2, negative 3. It would be from like negative 3 to 2 of the top function, which is f of y, minus the bottom function, which is g of y, in respect to y. So that's where we do the dy. Okay? Now, these bounds right here are a little tricky. Just know that you are not rotating your head when you're looking at bounds like that. The only time that I want you to rotate your head to figure out this piece, which is top minus bottom, this is when I want you to rotate your head. And when I mean rotating your head, you're going to rotate your head like 90 degrees to where you look at this like now as your top, and this is now as your right. And now you can see that if your head is tilted, this is the top function. And where would the bottom function be? Well, it would be the one that is right here. So if you're not tilting your head, it's the furthest right minus the furthest left. Okay? I like to tilt my head and show as far as like what those top and bottoms will equal. And then that will give you this area all right here. Any questions so far? No? Okay. So let's go ahead and start our first example. Y is equal to x squared plus 2. This is my first function. Y is equal to negative x. That's my next function. What does x equals 0 look like? Vertical line at the y-axis, right? Okay, so there's x equals 0. And then x is equal to 1 is right here. Now, the area bounded, okay, so we're looking at this area bounded stuff. This is where the area is bounded, basically outlined by all of these boundaries. And then you're just coloring in just like you did in kindergarten when you were coloring. Just stay in the lines. That is your shaded region that you're looking for, the area for. Now, first step. Step 1 says, is it dx or is it dy? Remember, dx are vertical slices throughout the entire area, and dy are horizontal slices throughout the entire area. Our goal is to have the least amount of integrals to set up as possible. So what do you think I should do, dx or dy? Okay, so let me show you the difference. If we did dx, that means across this entire thing we're doing vertical slices. What's my top function? X squared plus 2, right? It's the red one, right here. Is it always the top in that entire interval? Yes. What's the bottom function? The blue one, right? Which is what? Negative x, yes. Is it always the bottom? Okay, because throughout this entire thing I have one top and one bottom, all I have to worry about is one integral. You with me? And it'll be dx. That's step 1. Okay? Step 2. What are the bounds? What's your low x value? 0, yeah. And what's your high x value? 1. Because again, you're going from these 0 to 1. Let me highlight it in orange. You're going from this left all the way to that right. And it's going to go through like that. Like an arrow, if you will. You with me? And what is the top function? Do we have to rotate our head, yes or no? No, we only rotate it with dy. So just normal looking at it, this is going to be, the top function is x squared plus 2. Notice the use of parentheses. Minus negative x. Got to be careful with these parentheses, otherwise you might miss it by negative. And then from here, we'll just finish it off. So it'll be from 0 to 1 of x squared plus x plus 2 dx. The integral is x cubed over 3 plus x squared over 2, right? Plus 2x, all evaluated from 0 to 1. And if you plug all that in, you know the zeros are going to cancel out. And I get 1/3 plus 1/2 plus 2, which common denominator of 6, would change this to 2/6, 3/6, and 12/6. So 17/6 units squared would be the area that we just solved for. Real quick. This is fast, this is efficient. It was a good choice for you to use the dx instead of the dy, and I'll show you why right now. Because if we use the dy, notice the change. Okay, so first let me get this back. Here we go. So again, I want the top over the bottom the entire time. Notice this. Orange, I have to rotate my head if I'm doing dy. Orange is on top of red. 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 There's one integral. Now, orange is on top of orange. Orange is on top of orange. It's on top of that other function. All the way to here. The top is 1, right here. And the bottom is 0. You with me? Okay. And then the last part goes orange on top of blue, orange on top of blue, orange on top of blue. How many integrals would you see? 3. We don't want to do more than what we need to because there's more room for error. So that's how you choose. Oh, I forgot to put step 3 is what is the top minus bottom. Okay? Alright. Let's do this one. We have 3 minus x squared, which it's a quadratic that's been flipped down and shifted up 3 units. Okay, let me draw that a little bit better. And then we have negative x plus 1, which is a slope of negative 1 but shifted up 1 unit. You with me? Now, my shaded region is everything that has been bounded by these 2 graphs. Basically, I can only color in between the lines right here, nowhere else. And I want to find the shaded region. Step 1. dx or dy. What do y'all think? Dx. It would be dx because red is always going to be on top of blue. Now let me highlight that so you can see it. This red is on top of this blue. Right here, this red is on top of this blue for these particular sections. You with me? Alright, so dx it is. Real quick, if I did dy, let me show you why you can't do it, because you're not always going to pick correctly the first time. Right here, all the way down, what's on top of what? What color is on top of the other one? Red's on top of blue. But right here, what's on what? Red's on red, and you can't have that. Now I know this, just the last slide I said orange on orange, but it was 2 different functions. One was x is equal to 1, the other one was x is equal to 0. Here it's the same function. You cannot have the same function on top of itself, okay? Alright, so dx it is, horizontal or vertical slices. Okay, so again, dx is vertical, horizontal is dy. Alright. So step 1, we know it's going to be dx. We also know it's going to be one integral because it was throughout the entire time. What's your low? Step 2, what would the low and the high be? Negative, so it's whatever this x value is here, right? All the way to whatever this x value is here. And the best way to solve for that is to do what with these pieces? Set them equal to each other and solve. So we have 3 minus x squared is equal to negative x plus 1. I don't like to have these as negative coefficients, so I'll move everything to the right, and I'll get that. This is why we did algebra 2. Of course, a big reason, because we need to factor this to what? X minus 2 and x plus 1. That means the answers is x is equal to negative 1 and x is equal to 2. So what's my low right here? Negative 1. And my high is 2. So this is negative 1 and this is 2. Right? And these are x values, guys. So if I wanted to solve for the y, I would just plug these in into any one of these functions and then solve for the other one. So let's plug negative 1 in. It would give us 2, right? Let's plug in 2. It would give us negative 1. So negative 1, 2, and 2, negative 1 are the points, but all we care about are their x values because we're talking about things that are in respect to x. Make sense?
We'll only care about it later when we plug in.
Yeah, that as well. But we're not concerned with the y's is what I'm saying. We don't care about these when we're in x language. Okay? Alright, so what's the top function going to be? The red one, 3 minus x squared, yeah. Minus the bottom one, which is negative x plus 1. Now you notice this is very important, this parentheses and negative, because otherwise you're going to miss the fact that it's actually adding x and subtracting 1. So you would have negative x squared plus x all manipulated. 3 minus 1 is plus 2. Negative 1 to 2 dx. And then you would have negative x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. Now be careful with this negative here, because when you put in 2 here, it's going to become a negative 2 cubed is 8. Then multiply by that negative, so you get negative 8/3. And then plus what? 4 over 2? So just 2 and then plus 4. All subtracting, plug in the negative 1. So let's plug in the negative 1. Negative 1 cubed is negative 1. Times this negative becomes a positive 1/3. Then you're going to do, that's a positive. And this is a minus 2. You with me? And you get all common denominators, and then you can get your answer from there. Just make sure that you don't mess up this negative 1 when you plug it in, as far as you would get. And then for the sake of time, I'll let you finish that up and do units squared.